The next type of transformation that we're going to talk about are rotations. Now, a rotation is a transformation that rotates every point of the pre-image through a specified angle and direction. So rotates goes there. Again, remember the pre-image is the first one, and the image is where we're going to end up. That has a prime. Okay? When a figure has rotational symmetry, we say that it can be rotated less than 360 degrees around a central point, and that will map the figure onto itself. Just put that down. When we see an example, you'll understand a little bit more. When we say something has point symmetry, we say that it has rotational symmetry of exactly 180 degrees. What that means is we can turn it halfway around the circle and it'll look just like it did before. Okay? So let's look at some examples here. Let's look at number 1 here. It says, does this figure have rotational symmetry, point symmetry, or neither? If it has rotational symmetry, we want to state the angle of rotation. Okay, so for A, first of all, we know that all the way around is going to be 360 degrees. If it can be rotated less than 360 and map onto itself, then it's going to have rotational symmetry. In order to see that, we have to know how far we rotated, what fraction of the circle, to find out the degree or the angle of rotation. Well, to do that, we know the whole thing is going to be 360, and we can rotate this once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times until it maps back onto itself. So for each angle, it's going to be 360 divided by 8. Do 360 divided by 8, that gives us 45 degrees for the angle of rotation. So if we go from here to here, it's 45. This would be 90. This would be another 45. This would be 180 down here, halfway around, and so on. Okay? So it does have rotational symmetry. So let's just put an R up here for rotational, and we show the 45 down there. And does it have point symmetry? Can we rotate it exactly halfway around? Yes, we can. So it also has point symmetry. So R and P would work on that. So that's B, or that's A. Let's look at B. B is right here, and it's a triangle. Okay, now, can we rotate this less than 360 degrees so it will look just like it does? Well, if we rotate this point around to here, it'll all look the same. And if we rotate it here, it would be the same. And then back to here, it would be 360 degrees. So this time we're going to do 360 divided by 3, and that gives us 120 for a degree of rotation. So this does have rotational symmetry. Now look at this one. Now, does it have point? Can we rotate it halfway around, and would it look exactly the same? Now, if we rotate this halfway around, put the point down here, the triangle would look like this. So it does not have point symmetry, so it's just rotational. Okay, for C, got this semicircle here. Well, we can't rotate it halfway around because then it would just be upside down. We'd have to rotate it all the way around to get it to map onto itself. So that's 360. Rotational has to be less than 360, so it doesn't have rotational. Since we can't rotate it halfway around to map onto itself, it doesn't have that. So your answer for this would be neither. For D, let's see, it looks like we have a regular hexagon here. We could rotate this point around to here and it would look the same, and here would look the same, so each one of these points would be the same. So this time we're going to do 360 divided by number of points, 1, 2, 3, 4, 5, 6. So our angle of rotation is going to be 60 degrees. Every time we rotate this, it's going to be 60 degrees. So this does have rotational symmetry. Now, does it have point symmetry? Can we rotate it halfway around and would it look the same? Well, yes, we did. we rotate this around to here, it would look the same, so it also has point symmetry. And that's example 1. Let's look at example 2. What is the image of the point with a 144 degrees clockwise rotation of R, and then we want an image of a point with a 288 degree counterclockwise rotation of N. Okay, so first of all, clockwise, just a little reminder here, clockwise is going to go this way. Okay, counterclockwise would go the other way. Okay, so we want to do 144 degrees clockwise. First of all, we have to decide how many degrees each rotation would be. So we've got 5 points. We know it's going to be 360 all the way around. So if we do 360 divided by 5, that tells us that every rotation is going to be 72 degrees. So from E to R, if we rotate that around there, it would be 72. Okay, so we're starting at R this time. We're going 144 degrees. Well, we know each rotation is 72. So if we do 144 divided by 72, that tells us that we have to rotate it twice. So we're starting at R, right here, and we're going to do 144 degrees clockwise, or 2 times clockwise. So clockwise, we're going around this way, so we're going from here to here and to here. So that would be Y. So our answer would be point Y on that. For the next one, it says, what is the image of the point with a 288 degree counterclockwise rotation of N? Okay, again, we already know that each one of these is going to be 72, so we don't have to do that again. If we do 288 divided by 72, that would give us 4. So we have to go 4 times counterclockwise from N. So we're going to start right here, going counterclockwise backwards. So we're going to go 1, 2, 3, 4. So our answer is E. Point E. There's a point. Now we want to sketch a 90-degree clockwise rotation of the flag below about point R. So clockwise again, going around that direction. So if we go 90 degrees, we know the whole circle is 360, 90. We need a reminder. 360 divided by 90 is 4, so we're going to go 1/4 of the way around, so this is going to be standing straight up. The flag will be pointing in this direction there. So your answer should look like that. Technically this should be the same distance away from R, but it should be in that position. Okay, let's look at the next one. Example 4. We're going to rotate triangle PQS around point R 90 degrees counterclockwise. Okay, so counterclockwise, remember we're going this way. Okay, we're starting here. Well, the best way to do this would be to draw, if we draw a line from this point to R, we're going to rotate this line around like this because we're going counterclockwise. 90 degrees is 1/4 of the circle, so the new line is going to be here. Okay, and then our triangle is going to come out like this. Just like I did last time. Up here at the top is going to be Q. Okay, and we know P went around to this side, so P would be here, and then this would be S up here. And that's example 4. Okay, next, let's draw a 180 degree clockwise rotation around point Z, LMJR. Well, we know 180 degrees is going to be halfway around the circle. Okay, so if we do this, let's draw M to here. We're going to go 180 degrees, so our new one's going to be coming out here. Okay, now this gets a little tricky here, so we have to let's see, let's draw this. Let me erase that. take that off of there. We've got that going there, so we want to have the same. Okay, that's good. Yeah, right there. Okay, so an angle on there. So this one is going to have been flipped like this. Okay, that gets rotated around. One where the line is coming off, this is going to be M now. Okay, it's around there. And then L will be on this side. Across from M would be J, and R would be here. And if you get patty paper, you can check that and make sure that that's correct. Okay, number 6. It says the figure has been rotated about point P. Determine which vertices correspond to one another. And so we went from here, do Y to there. Okay, and we rotate that 180 degrees. Okay, so we go all the way around. The one closest is B, so Y equals B. Okay, around like that. So X is going to come around to 180 degrees. Okay, so we have Y equals to B. Across from the Y is W. Across from the B is D. So W equals D. Okay, and when we were rotating this around, the X was in front of the W, so in front of the D is going to be A, so X equals A, and Z equals C. And that is example 6. And we'll stop right there, and we'll pick up with dilations in the next video.